All right. So welcome viewers. Here we'll be looking at some exercises for section 6.4. And the first one is asking us to find the vertical asymptotes of the function y equals to minus cosec, right? So how do we solve this kind of question? You know, this one we can rewrite y as 1 minus, this is half. And since this is cosec, then this will just become sine x minus 3 pi over 4, right? This is just reciprocal here. So now we're interested in the vertical asymptote. So vertical asymptote means the denominator, which is, we can use 2 sine or we can just take sine. If you use 2, it's still fine. You'll get the same thing because we can always divide by 2. And this means that x minus 3 pi over 4 is equals to what? Is equals to n pi. But here our n is an integer. And so that means that what? We can solve for x easily. So x is equals to 3 pi over 4 plus n pi. Which we can write as, we can take pi as a common factor. So we just have 3 over 4 plus n. So this is the general equation for the vertical asymptotes, but we're interested in the vertical asymptotes that are between 0 and 3 pi. So we want x to be between 0 and 3 pi. And that simply means that we want this to happen here. 3 over 4 plus n to be less than 3 pi. Clearly, we can divide both sides by pi, so we just have 0 less than 3 over 4 plus n less than 3. And then we can multiply both sides by 4 so that this is still 0. And this will be 3 plus 4n. And this is going to be 12. So we have minus 3 is less than 4n is less than 12. If we divide both sides by 4, we will have minus 3 over 4 is less than equals to n, and is less than equals to 3. Okay. All right, now let's see if this is 0, minus 3 over 4 is going to be somewhere here, and 3 is somewhere here. So we want to see how many integers we can get between these two. Remember, this is closed, this is also closed. So you can see it means n could be 0, n could be 1, n could be 2, and also n could be 3. So these are the possible n: 0, 1, 2, 3. Right, correct. All right. So what next can we do? We just need to come back here and substitute. For example, if n is equals to 0, if n is equals to 0, one of the vertical asymptotes, it's going to be 1. It's going to be, all right, so here we can think, I think there is something wrong here. If you look at here where we subtracted, there's supposed to be a subtraction here. This is not completely true. because when we get to this interval, we're supposed to subtract 3 from both sides. So here it's going to be 12 minus 3. So here it's going to be 9, right? Here it's going to be 9. So now we have to divide by 4. So this will be less than n less than equals to 9 divided by 4. So it means what we're actually working with is minus 3 over 4 and what? 9 over 4, right? So here, what are the integers? We can have 0 somewhere here. We can have 1. We can also have 2. Because you can see 9 over 4, it's not up to what? It's not, it's more than 2, but not up to 3, right? So this is the interval. So it means the only possible n are 0, 1, and what? And 2. So if n is equals to 0, x will be what? Just substitute it back into this formula. You will have 3 pi over 4. Now, if n is equals to 1, if n is equals to 1, it will be what? It's going to be pi. So you have 7 pi over 4. And if n is equals to 2, we will have equals to 2. So you can multiply it by 2. So you have 2. So we can multiply it by 4, which will be 8. So it's going to be 11 pi over 4. Now, these are the vertical asymptotes. So let's put the vertical, all of these are the vertical asymptotes now. Then you can add. So what will be the sum? The sum will just be, or you can call them your A. So let's do it this way. Now this is our A, this is our B, and this is our C. Because from the question, we're told x equals to A, x is equals to B. So, and x is equals to C, these are the vertical asymptotes. So the sum is just going to be A plus B plus C, which will be what? What is A? So we have 3 pi over 4 plus 7 pi over 4 plus 11 pi over 4. And this is clearly 21 pi over 4. So another way to solve that is that we can just graph it, right? We could graph it directly without using the analytical method. Okay, so let's see question number 2. This is question number 2. For question number 2, we're asked to what? To graph. We want to see the graph of this function, which is 2 sec. Now, to graph this one, what can we do? We just need to find our period, because this is the graph of sec. So we will graph we will go with the helper. I mean, we need to just graph 2 cosine x minus pi over 2. So to graph this, what do we need to do? We need to first of all find the amplitude is given, which is absolute value of 2, which is 2. And this is the cosine, so the period is 2 pi over k. And this is going to be 2 pi over 1, because our k is 1, which is 2 pi. And then you can find the horizontal shift. x is equals to minus b over k. So clearly, this is going to be minus pi over 2 all over 1. And this means x is equals to pi over 2, right? All right, so now how do we graph this one? Since the period is 2 pi, so we're supposed to have something like this. It's supposed to be between 0 and 2 pi ordinarily, yes, because the period is what is 2 pi. So we shift this, we split this into 4, right? But as we can see that we have what? We have a shift, which is pi over 2. So it means we have to what? We have to add pi over 2 to each of this interval because we have positive, so it means you are shifting to the right. So we have to add pi over 2 to each interval. All right. So once we have that, now let's come here and plot the graph. It means we will work with what? From pi over 2. And this is going to be pi, right? And then this will be 3 pi by 2. This and this will be just 2 pi. And this will be 5 pi over 2. All right, so the maximum is going to be 2 and 1 minus 2. As you can see, we don't have vertical shifts for this graph. So since it's the graph of cosine, it means that what? At pi over 2, we're going to the maximum, which is 2. At pi, we'll be back to the baseline. Then at 3 pi over 2, we'll be back to the minimum. At 2 pi, we'll be back to the baseline. Then at 5 pi over 2, so it's going to be something like this. Right. Okay. Now, if you look at this, you'll see that we will have our vertical asymptote at where? The vertical asymptote would be at the zeros, right? The vertical asymptote will be at the zeros. So let's see it now. This will be the vertical asymptote. So it means that what we are actually looking for, our graph of interest will be which one? The one in black here. And this is going to go like this. And this is going to go like this. Because we're interested in the cosine graph, right? Okay. So the red one is the helper, don't forget. And the one we're interested in is in the black one. So you can see that's what is correct about the graph. Let's look at the options. It says the graph of the function has a. Now, does it have a vertical asymptote at 5 pi over 2? No, the answer is no, because at 5 pi over 2, we don't have a vertical asymptote, right? Now, Is it increasing from pi over 2 to pi? Yes. As you can see, from pi over 2 to pi, the function is what? Is increasing. Now, is it decreasing from pi to 2 pi? Where is pi? From pi to 2 pi? No, it's not. So the only correct answer here is what? Is B. And you can see it is increasing from where? From pi over 2 to where? To pi. So this function is increasing, right? But look at E. If you look at E, what does E says? E says that the graph is above the x-axis on the interval 3 pi over 2 to 2 pi. Now, where's 3 pi? You can see that 3 pi over 2, from 3 pi over 2 to 2 pi, the function is what? Is actually below the x-axis because we're dealing with the green one, right? You see, from 3 pi over 2 to 2 pi, the function is below the x-axis. All right. So the only correct option is B. All right, now let's look at number 3. It says if f of x is equals to minus tan b of x, and a is greater than 0, b is greater than 0, is a function of period 3, then you want to find what is f of what? What is f of 3 over 4? Now, this is, what do we do here? We already told that the period, this is a tan graph, so we have to use this information. We know the period for tan is what? Is pi over k. So it means the period is 3. So 3 is equals to pi over. Now, what is taking the position of k here? Here we don't have k, remember? This is in the form of a tan kx. But here we don't have k, we have b. So we're going to use pi over b. So with this, it means that 3b equals to pi. And this means that b is going to be pi over what? Pi over 3. So once we have b, we can put it back. So it means our function f of x is going to be minus a tan of b. b is pi over 3 now of x. So this is just from here, right? We just replace b, which we got. So that's it. Now we want to find f of what? 3 over 4 is what? Minus a tan pi over 3 multiplied by x. What is x? X is also 3 over 4. So this will give us 3 over 4 is equals to minus a tan. 3 will go with 3, so this is just pi over 4, right? So it means that f of 3 over 4 equals to what? Minus a times tan pi over 4 is 1, yeah? So this is just minus a. Okay. All right, then this one is, we want to graph, also want to graph that of sec. Now to graph sec, what do we do? we start with the helper as usual. So let's go for the helper first. So what would be the helper in this case? Is going to be y is equals to 2 cosine pi x minus what? Minus 3 pi. And what it means is that we can find the amplitude from here. Our amplitude is just the absolute value of minus 2, which is 2. And the period is 2 pi over k, which is going to be 2 pi over what? Over pi. And this is equals to 2, right? Then we can see we have a horizontal shift. One way to find the horizontal shift, if you don't want to use the formula, just take this one. You said pi x minus 3 pi equals to 0, and solve for what? And solve for x, right? And clearly here, you will see that pi x is equals to what? 3 pi. So x is equals to 3. X is equals to 3, right? Okay. All right. Now, if we look at this one, what can we say? We can try to sketch the graph directly, but it's always good we know our interval. But in this question, we are given this interval. We want our graph to be in this interval. So let us not worry. Let's look at the original interval first. Now, since we have the period is 2, originally we're supposed to graph from where? We're supposed to graph from 0 to where? This is what we're supposed to do, from 0 to 2. And now we need to split this into 4. This is going to be 1. This is going to be what? Half. And this is going to be 3 over 2. But you can see that you have a horizontal shift of where? Of 3. So we're supposed to add what? Supposed to add 3. So let's say you add 3 here. We add 3 here. Add 3. We add 3. We add 3. All right. So it means that once we do that, this is going to be 3. And this is going to be 3.5. So this we have 1 plus 3. So we can just make it to be the same LCD. This can become 6 over 2, right? So this will be 7 over 2. Now, 7 over 2. So if you look here now, this will be what? This will be 4. Now, this is what? This you can write it as what? So you can write this as 6 over 2. So you have 9 over 2. And then this will give us what? 5. But if you look now, this is actually what it's supposed to be. But if you look at the question has its own interval that is interested in. Is interested in where? In which interval? From minus half to where? 7 over 2. So it means that actually this interval will not really work. But we can use this interval. We can still use this interval. It's still going to be helpful. In what sense? If we see that, you will see that what? The distance between each interval is about what? 0.5. So you see that here is what? Is half, right? The distance from here to here is also half. The distance from here to here is also half. The distance from here to here is half. Okay? Now, since we have all of this, then all we need to do is just to go to the left, because we need to go to minus 1/2. So what I will do now is we will extend this one to the left. So let me extend this line. So I will extend this one now. This is the addition, the one I'm adding. So if this is 3, definitely this is going to be 2.5, right? Which is going to be like 2.5. And this is going to be what? 2. This is going to be 1.5, which is, and this is going to be what? 1. This is going to be 0.5, which is half. This is going to be 0. And this is going to be minus what? Minus half. Now, you see, what we are actually interested is that we are interested from where? From minus half to where? To 7/7/2, right? So that is the interval we are going to use for this. All right, now it means that to graph, we will focus on what? We will focus from minus half to where? To 7/2. So this will be 0. This will be half. This will be 3/2. 2, 5/2, and 3. Let me use the red. 3, and then what? 7/2, which is 3.5. So this actually, all right. So to graph this, we have to look at the interval that we are interested in. We want to start from minus half to 0, half, 1, 3/2, 2, 5/2. Then, but the only thing we are getting from here, we need to use from this part is only 3 and 7/2. Okay. Now, if you look at this, you will see that, remember, the period of this graph is what? Is 2. The period is 2. And that's why you can see that the distance, you see the distance from here, from 3 to 5 is 2, which is the period. So it means we need a period of 2 also, so that we know where to start from. Now, if you take from 3 to what? To 1 is also another period 2, right? Okay. So now let's work with this first. Now let's draw our y-axis. So this is 2 and this is minus 2. So if we need a period of 2, let's say starting from 3, let's just start from 3, from 1 to 3. So you can see that from 1 to 3, this is one period because the interval is 2. So you can just start to plot from there and to give us an idea how we can proceed, right? Now, since if you take this as your starting point, it means at 1, what should happen at 1? At 1, you should be at the what? At the minimum, because this is the graph of what? Cosine. And not just the graph of cosine. We have the cosine, the graph of -2. So it means there is a reflection. So that is why we are starting from -2. right? Then if we go to 3/2, we will back towards the baseline. Then if you go to 2, we should be up here. Then we'll be back here. Then finally, we are down here. So you see, this is how the graph will look like in just one period, which is from 1 to 2. Then clearly you see how can you finish this graph? But you are interested from minus half. So if this is maximum, then here will have to be baseline. So it means you have to go like this. Then if this is the baseline, then at 0, it means you have to be at the what? At the maximum. Then at minus half, we have to start coming down here. Okay. But remember, here is going to be open simply because the interval is open at minus half. And here also, we can complete it. It means that here also is going to be open. So we have something like this. Now you can see that we have the vertical asymptotes. Where do we have vertical asymptotes? This will be the vertical asymptotes. Half, and at where 3/2, and also at, now here we cannot say they are vertical asymptote. You can say they are vertical asymptote, is fine, but 7/2 and this, they are not in the what? They are not in our interval because we're asked to find the graph between what? Minus half open, and also 7/2 is also open. So this is all we need. And this will be reflected in this way. So we have this, and then we have this down, and this is going to be up. And here also we're going to have something like this, right? So we're interested in the part that is what? That is below the x-axis, right? Yeah. So if you're looking for the part that is below the x-axis, so we'll see that it's just going to be from half to 3/2, and then from 5/2 to 7/5 open. So this is going to be this one here. So we have 1/2 to 3/2. This is where the graph is below the x-axis. All of this. Then what? Then from 5/2 to 7/2. 7/2 is open. So we have A is the right answer, because we're interested in the part where the graph is below the x-axis. All right, so let's look at this one. It says the graph of this over the interval. Now, the same way, we just need to sketch the graph of 3 sec. Let's deal with what is inside first. But to deal with what is inside, we need the helper graph, which is, right? This will be our helper. So the amplitude is what? Is 3. The period is 2 pi over k. What is 2 pi over k? 2 pi over k is 2 pi over 2/3. This is nothing but 2 pi times what? Over 2. which is just 3 pi. All right. So, and you can see that we don't have a a horizontal shift. So it means ordinarily we should graph from where our graph should start from 0 to 3 pi. So let's go and draw 0 to 3 pi. This is 0. This is 3 pi. If you divide this by 2, this is going to be 3 pi. 3 pi over 2. This is going to be 3 pi over 4. And this is 9 pi over 2, right? Yeah, because you will have 6 pi plus 3 pi. Now, this is what we're supposed to have here. So if we graph this, how is it going to look like? Let's say this is our A. What is our A? 3. So this is 3, and this is -3. So the graph is just going to be at 0, since it's the graph of cosine. We're going to be here, and then we'll back to the baseline, down to the minimum, up to the baseline, and up to the maximum. So we have this. Right. Now, the vertical asymptotes. Okay. And the vertical asymptote is not, we don't have a vertical asymptote as 3 pi over 2. Rather, we have a vertical asymptote at 9 pi. But now, if you look at the graph, we are only interested in which portion. When the portion 0 close to where? To 3 pi. So it means we have to just restrict ourselves to the domain of interest. So what is the domain of interest? This one to this. So we are not interested in all of this now. Okay, so it means you can see we only have one vertical asymptote, which is 3, which is what? Which is 3 pi. All right, 3 pi by 4. Now, how will the graph look like? The graph will just be, the graph of cosec now will look like this one. The graph of sec, I mean, because this is the graph of what? This is the graph of cosine. So it will look something like this. Okay. All right. So the purple one is the graph of what? This is the graph of 3 sec 2 over 3x. Okay. And we can also look at this part. How will this part look like? This part will be somehow like this, right? Okay. Ooh, right. Now we have an absolute value. So what does an absolute value look like? With this absolute value, it simply means that everything below the what? Below the x-axis, we're going to bring it back to the what? We're going to bring it up. Yes. Ooh. Now, if you look at it, but because of the absolute value, the red part here, not the red part, this purple part that is below the x-axis, we can need to reflect it across what? The x-axis. And if you reflect it across the x-axis, it will become something like, let me use another. Okay. So it will just be something like this as 3, right? This is coming from the reflection of this one. So what does that mean? It means that the line y equals to, because the question says we want to know the line, how many points would the line y equals to 4? How many times will it intersect the graph, right? All right, so if we reflect this part, which is below the x-axis, if you reflect it up, it's just going to be something like this. Yeah. Okay. So it means that if you draw the line y is equals to 4, but where's the line y is equals to 4? The line y is equals to 4 is going to be somewhere here. So if you draw the line, it's going to cut the graph where just at 2 points. This point, this point. So this is where it will cut the graph. So the answer should be, the right answer is B. Okay. So what did we do? First of all, you sketch this one. This is the helper graph, which is 3 cosine 2 over 3x. Yes. And then you have your sec. Your sec graph is 2 pieces. This is 1 piece, and this is the second piece. But now, because of the absolute value, you have to reflect this piece, right? This piece that is below the x-axis, you have to reflect it across the x-axis. So if it's starting from, if it is from minus infinity to minus 3, definitely it's going to be from 3 now going to where? To infinity. All right, so this is the end of the videos for video series for 6.4. If you are not yet subscribed, kindly do that. You can share with your friends as well. And you watch out for video series for section 6.5. Thank you for watching.